Okay, we'll start with our usual announcements. We have an exam this Friday. Woo. Study guide is up. We'll have a review session on Thursday. Let me know if you have any questions, clarification questions about that study guide ahead of time so that you don't get confused or study the wrong things or don't know something ahead of the exam. Then I guess we also have our decorator lab due on Wednesday. My plan is to assign and get the builder lab done pretty quickly. This one should be a little bit easier, I'm thinking. So we're gonna try to get that in and done so that you can start thinking about how to apply it to your project. I wanted to go over the project because we're going to be assigning this. It's basically going to be live today. It won't be due until the end of the quarter, but there is a significant design portion to this. And so I want people to start thinking about the design of their project now. If you put this off until the last week or two of the quarter, this is going to be very difficult. Last quarter, the feedback that I heard almost unanimously across the board was I underestimated the size of this project. And I was not able to get as much done with it as I wanted to. That was basically I heard that from almost everybody. They just wished they'd had more time, spent more time on it. So I am trying to give it to you about a week earlier than last quarter, and that will do absolutely nothing if people don't get started on it during that week. So just giving you an idea of what I am looking for with this project. This is very different from the labs that you've been doing in the course so far, because instead of having an API and no code, now there's no API and no code. And the idea is that you are going to completely design the solution for this from the ground up. And I'm not doing too much dictating about exactly what it looks like. So you have a lot of freedom as long as you adhere to the constraints of this document. So the document says you've been tasked with coming up with a prototype for a new airline ticket purchasing for a third-party site. You could think of something like Google Flights or some other kind of flight purchasing software. So you work for this company and your boss comes to you with the following instructions. So she says, the design and flow of the software should be clean and easy to use, whatever that means. I'm leaving that to you to figure out what does clean and easy to use mean. What it means from my perspective is I expect this to be easy to use. What does easy to use mean? I don't want to get confused. I always want to know what the program is doing from anything that matters from my perspective, but I also don't want to know a ton about the internal details about what's happening. We've talked about how the client often doesn't know everything that's going on underneath the hood when you're applying design patterns and there's some kind of complicated underlying structure. As the user, I don't want to know about that. I want to look at it and see it in your code, but I don't want it to be part of the interaction that I have with your driver. The code should be extendable. So your boss comes to you and she says, this is going to be a prototype. With prototypes, things are going to change in the near future. So because of this, don't hard code everything in a way that is going to be really difficult to change in the future or extend in the future. So we don't want to spend a lot of time refactoring our original design. So it'll be wise to use the strategy, decorator, and builder design patterns, all of which we've gone over in class. We've had labs for strategy and decorator. The next one will be for builder. What your reservation requires. A reservation will be made up of multiple tickets. And you can imagine taking your entire family on a trip. And that way, as you go to scan your tickets, you can just swipe in the app and you see the next ticket that's part of this reservation, the next ticket that's part of this reservation, the next ticket that's part of this reservation. You don't swipe and see tickets that are not part of your reservation. That would be weird to swipe and suddenly see a boarding ticket for someone behind you who you have no idea who that is. but you have access to their ticket. So how many tickets are part of this reservation? It's going to be part of the reservation. The total cost of the reservation. The cost of the reservation is going to be made up of the cost of each ticket. The cost of each ticket is going to be made up of some factors. You have a little bit of freedom in terms of those factors, but you need to have some factors present. So seat class is one way that you may be able to include some of that. You may be able to decorate a seat with a premium seat or a first class seat as a way of saying, when I buy this ticket, I can decorate that ticket with a first class experience. That may change the cost of the ticket. How many checked bags are there with that ticket? That may change the total cost of the reservation because it changes the cost of a particular ticket that's part of that reservation. Then your reservation will also tell you the aircraft that you will be flying on. The aircraft has some kind of name, you know, maybe a Boeing 737-6, I have no idea, I don't know aircrafts that well. You can make up names as well. I don't care if it's a realistic, you can make this as realistic as you would like. You could decide that your reservation is on a helicopter. You could decide that your reservation is on a spaceship. I don't care what the airplane, what it is, as long as you adhere to the design patterns for the most part. So you can have a little bit of fun with this if you'd like to. So an aircraft needs a name, a number of rows, and a number of seats per row. So you know that aircraft have something like 17 rows on a small aircraft, each of which have 4 seats per row, A, B, C, and D, 2 on each side of the aisle, if it's a really small local craft. Or you could have a larger craft that is 3 by 2 by 3 in a particular setup. You may have a helicopter that's a single row with 2 seats, but that should be customizable on a per aircraft basis. Your flight will have some number of layovers. You will need to know the associated airport codes and hours and minutes of each layover for each one of the layovers. We need to know the date and time of the flight. We need to know the source and destination airport codes, and we also need to know the name of the airline you are flying. That is all on the reservation. Each ticket is going to have the full name of the flyer, the flyer's date of birth, the seat class, which I give you here as first class, comfort, or economy. And you can, of course, change this. I just want there to be some kind of seat class that you can choose from. The seat number, the boarding class, you can use any system that makes sense. You could also use the strategy design pattern to change the associated boarding class and the boarding class logic based on which airline you have or which airline you are flying. And there's an optional number of checked bags. So this is all that I am saying needs to be there. How exactly you do this is completely up to you, as long as you include somewhere a strategy design pattern, which means you have something algorithmatized, if that's even a word. There are algorithms for something. And they can be swappable at runtime. So let's see. I also expect a one-page single-space write-up. And in that write-up, you will tell me where each design pattern was implemented in your code. So give names of files and line numbers of your code to say, here's where you can go find my strategy design pattern. It's in these classes that are composed in this place in these classes. Here's where the decorator is. Here's what I did. So document where, class names and line numbers, and then describe the benefit you get from using that design pattern. Pretend like you're talking to your boss when she said above that this is a prototype and should be extendable. Talk about how your implementation works well with a prototype and why it's extendable after you've used that particular design pattern. Give a short description of drawbacks or any other considerations that you would need after you've applied strategy and decorator and builder to your code. I have some hints here for you. So the builder pattern I would expect is going to be done with the reservation constructor. So rather than having a method for that, you're gonna make a class-based construction. You could either make a reservation builder or you could make a ticket builder. One of those is going to make way more sense than the other. I will leave it up to you to decide whether you want to build your reservation step by step or whether you want to build a ticket step by step, or both. Use a decorator. You can wrap your flight information with the appropriate ticket customization options. So this could be something like, how are you going to calculate your price? If this is composed of the number of checked bags, you could do something like wrap a ticket in a checked bag, another checked bag, and then a first class seat. And then when you wanted to get the cost of the ticket, you could recursively call the get cost of each of these wrapped classes and end up with a total cost of each ticket from using decorator. Strategy could encapsulate any behaviors or algorithms, either the boarding process, or if each plane has a fly method that prints out the noise that it makes when it flies, vroom. Who knows? Have fun with this. You can be a little silly if you'd like to. Again, I'm not expecting this to be 100% perfectly professional. I'm mostly just looking for the design patterns. And then use inheritance hierarchies for things like the airline. You're going to have a generic airline class, and you're going to extend that or implement that for every airline, each concrete airline. Do the same thing for airplane. You'll have either an airplane interface or an airplane abstract class, depending on whichever one makes more sense. And then you'll have a bunch of concrete instantiable classes to make different kinds of airplanes. And then the same thing for airports. Since we know that we need a source and a destination airport, you could add some extra information to airports to maybe have other fields like the number of concourses or the length of a delay when you take off or land, or you can decide what you want here. I had someone put an airport on the moon, and you could only get to that airport if you instantiated an airplane that was a spaceship. You can have fun with this. And then grading. I actually need to rework this grading, which is the reason I haven't published this yet, because nowhere in this grading are there any points for your write-up. So I will be changing this to make sure that your write-up is also graded. But for the most part, most of it is in the functionality and design. I'll probably take a little bit away from the unit tests and documentation, so something like 10 points from the unit tests, 5 points from the documentation. And that will be the grade for your write-up, something like that. But again, this is due by the end of the quarter. This isn't something that's immediately due, but I would start designing now. I would start thinking about and creating UMLs. Start actually designing what is the actual class functionality of this, and then identify where is the strategy design pattern in this? Where is the decorator design pattern in this? And kind of make a box around some of your UML class diagrams that says, here is the pattern, and make sure that you map it to Refactoring Guru and make sure that you have the associated classes. If you don't have a director class associated with your reservation builder or ticket builder, then there's an issue. It's not adhering to the builder design pattern. So you're going to need to think about how do you actually use all of the design patterns that we've covered to make an actually large usable application. This is still kind of a toy application. It's not going to do anything real, but at least it will have us using everything in the class that we've seen so far. Does anyone have any questions about the concept of the project? How to get started on the project? Whether certain things are okay or not for the project?
So for the write-up, should we include diagrams or just words? Like diagrams like UML and also the arrows pointing from one.
You could include a UML if you would like to. I can mostly see that from the code, but it's good to just kind of zoom out and see. So yeah, if you wanted to include the UML and then have boxes around each design pattern that you've used to say, here's where this is, here's where this is. when I say to like give class names and line numbers, you could just put a subtext under the class diagram that says the associated line numbers of the strategy design pattern. If you were to, put a box around that in the UML, that would give me the names of the classes embedded in picture form. That's perfectly fine.
And this project is gonna be the last one for this class. So it is okay to borrow code from the decorator and the other lab that you are gonna
Oh, yeah.
do the builder, so combine
Yeah.
the.
If you wanna borrow logic from that, the other thing that I recommend is going to Refactoring Guru. And I think I mentioned this, but under the different design patterns, if you go to, for instance, the creational pattern, the builder pattern, and you scroll all the way to the bottom. First of all, there's pseudocode on the main page, but if you scroll all the way past the pseudocode, you can see that there's a Java implementation of a code example. So here's like the step-by-step. Here's the actual Java code for this example of the builder constructing a car step-by-step, a car and a car manual side by side. So I would say use this as an example. You're welcome to go borrow most of this form and functionality and just change it to be something that's associated with an airline reservation, but keep most of the class structure intact. Yeah, I don't expect you to come up with all of this on your own necessarily. Utilize some resources that are out there. Just don't copy someone else's exact code and then call it yours. If you want to use this as a design, see what's in common between this project that's been this code and the code that I need to write, perfectly fine. So I think Refactoring Guru will be a very good site for this. The labs that we've done will be good for this. Just make sure that it adheres to the design patterns. Great questions so far. Any others? All right, we are going to start diving into new design patterns. And these design patterns don't have projects associated with them for this course, but there will be labs like the labs that you're currently working on eventually for them. I want to take a little bit of time to focus on the design of the project. And I know the builder lab is still forthcoming, so we are focusing on that next. But so our class work is a little bit ahead of our lab work, which is a little bit unfortunate. I'd like to catch up on that a little bit if possible, but I also don't want to rush people. So we are going to be talking about the factory design pattern next, another creational pattern. And this is going to be a big one. In fact, this is probably the single most complicated design pattern we're going to cover in here. So it's probably a 3 or 4 day task. This is a big one. It's going to take a long time to cover. Also, we're going to be talking a lot about food in here this week. So if this is going to bother you, eat before you come. I know this is right during lunchtime, but if you don't, you're going to leave here very hungry. So we're going to be doing a lot of talking about pizza. So this is our second creational pattern that we've covered. So maybe we should talk just a little bit and recap the builder pattern before we dive into factory and how factory is different from builder, because I think that can get a little bit confusing as we start talking about factory. So can anyone summarize the builder pattern? What was builder? What did we use it for? Why would we choose to use the builder design pattern? Time to go dig through your notes. Even at a high level? Anyone? Bueller. Bueller.
What do you want, just the definition of it?
It's kind of an overview of the builder pattern. What do we use it for? When would we choose to use it? It's been a little while.
Is it kind of like a blueprint?
So we want to construct an object. Do we know everything about this construction right away? No, we're gonna build it step by step. So that's either gonna involve a long parameter list, or it's going to involve constant communication with the end user, where the user fills out a form, fills out another form, maybe we wait a little while, they come back to it later, but you want to be constructing as much of it as you have the information for on the fly. We talked about there being a director. The user is going to be communicating directly with the director. And the director is going to be communicating with the builder interface that's going to be creating the concrete builders. So user talks to director, director talks to the builder, and the builder, the concrete builders. That way, the user can't directly call any of the builder methods. Only the director can call the builder methods. And there is a middleman, this director, keeping track of what is the user passing me, collecting all of that information, and once it has enough information to call one of the builder methods, then it does so and constructs the object, kind of assembles the object before it passes it back to the user. But from the user's perspective, all they did was send in some information. So it's the user is very blind to what's going on underneath the hood. So that's the builder design pattern. We use it when we want to construct something step by step, when we want to delay the construction of an object, and when we want to utilize some of the features of a class rather than the features of a method when we are constructing an object. Because normally we call a constructor method, and now we have a whole class, the director, to engage with, which gives us the ability to include the features of a class in object construction. So I have another broad question for people. How do we use the new keyword? What does new do for us? Yeah?
Copy or creation.
Yeah, the creation of an object. We can't make an object without the new keyword. We could say person P equals something, but that would be a shallow copy of an existing object. When we want to create an object, we have to use the new keyword. That gives us a new object. Note though that it has to be an instantiable object, so we can't call new on an abstract class or an interface. It has to be a concrete object. This design pattern is going to come into play when we don't know until runtime which concrete class we're going to want to instantiate. You can imagine that we have an interface. And maybe this is the list interface, and we want to give the user a choice. Do you want to make an array list, or do you want to make a linked list? How would you write a driver to do this? We can't just assume the kind of list that the user wants to make. We can't write the code for equals new array list, equals new linked list, and we can't say equals new list, because list is not an instantiable type. It's an interface. So you have to either say new array list or new linked list. How would you solve this? It's totally doable. If you're in 300, we've done something like this before, this quarter.
Make a menu.
Yeah, you have some kind of driver and you have to ask the user, what do you want to create? And then you use a conditional statement, like an if statement that says, if they pressed 1, make an array list. If they pressed 2, make a linked list. But we need some kind of interaction at runtime to know which one to make, which means that we need to have some kind of condition block. If there's more than just array list and linked list, then we can have a really big conditional block that tells which constructor to call based on some really long parameter list. So we end up with something like, we need to say new on a concrete type. We can store it as a generic type, as an interface or abstract type. But we end up needing to create a conditional block to determine which actual concrete object we want to instantiate. Does that make sense? Questions about that? Just kind of the way we have to do it. So of course, the issue with this is extendability. We see this in every design pattern, basically. What happens if we want to add a new, in the example on the prior slide, a new duct type to our construction list of possible constructible ducts?
Have to add another if.
Add another else if? What if we are calling this construction code in multiple different classes? Then you have to add a different else if to every conditional block, and you need to keep track of where all of these different conditional blocks are. What happens if you miss one? Can't construct that duct type from that place in the code, which is either going to look weird, be an eventual bug that you have to find, or a user is going to find. So it's kind of a logistical nightmare, and it means that this concept is coupled to the design. So the actual different duct types are coupled, the construction of ducts are coupled to the types of ducts that you want to construct. Which means that whenever you want to change the ducts that you want to construct, you have to change all of the places that could construct the ducts every time you want to add a new duct, or remove an existing duct, or modify how an existing duct is constructed. All of that is going to need to change in multiple places in your code. And when you have a large scale project, maybe you can keep 2 or 3 of these ideas in your mind, but in a large scale project, you might have hundreds of these. So maintenance will be an absolute nightmare. You're not going to know exactly which classes have which structures, and which means that your manager comes to you and tells you that a certain change is needed. You're going to have to do a whole code search over all of the hundreds or thousands of classes across your application to try to find where is this happening. And if you're modifying existing code, you may be introducing bugs, you may not be considering another aspect of the design. So that maintenance process is very error prone, and you're going to be relying on the quality of your tests to catch bugs that you're going to introduce by doing said maintenance. Back to the new keyword. Limitations. Is there a design pattern or object-oriented idea that we have talked about that is relevant here? We would prefer to program to an interface rather than an implementation. We've heard this before, right? We want to program to the generic and then let the generic figure out what is the precise, what is the concrete type right now, go call that associated code. So you want to code through the interface and not couple your code to the concrete classes. And if you write a driver that says, if the user does this, then instantiate that. If the user says this, then implement that. And that's multiple places in your code, you're not coding to the interface, you're coding directly to the implementation. If we write code to an interface, it works with any class that inherits from that interface. If we write through the concrete class, then if the concrete class changes, or we add concrete classes, or we remove a concrete class, then we have to go make those changes everywhere. So we much prefer to program to an interface rather than an implementation. So we would like some way to instantiate multiple different kinds of objects without having to worry about these large concrete if blocks. So this leads us back to this concept of the open close principle. We want our code to be closed for modification, which means that we can't modify the existing code. We don't want to have to modify the existing code to make the change that we want to make. We can extend it, but we don't want to modify it. So this entire idea just kind of falls flat very quickly. And it's not obvious what we want to do about it. This is where the factory design pattern starts to come in, because it's going to save us from this issue at the cost of our sanity. So how do we proceed? Another of the object-oriented principles that we've talked about is separate what varies from what stays the same. We want to encapsulate what varies so that we can interact with what varies. So how do we determine in a given program what varies? The example that we're going to be running with, I spoiled this earlier, hope you're not hungry. We're going to look at a pizza shop. And for the next few days, we're going to get very sick of talking about pizza shops. So here's some initial code. We want to create the structure to order a pizza. So we're going to instantiate a new pizza. And then we're going to, on that pizza object, prepare that pizza, bake that pizza, cut that pizza, box that pizza, and then return it so that it can be delivered or picked up or whatever the end user wants to do with this pizza that we've made for them. But that's not part of the pizza's constructor. The pizza's constructor just figures out what should be on the pizza. What is the style of the pizza?
Why does you want the constructor to make the initial pizza, pick that pizza object, put it big or accept.
Exactly. So that's exactly what this code is doing.
Like obviously you want to make the pizza itself first, bake the toppings, whatever you want it.
Yeah, so
And
we
then
need those customization options of some kind. But a lot of that's gonna come from the user, and you can imagine that that would explode in terms of something like a driver class that says, what toppings do you want? Maybe this starts to sound somewhat like a builder. If this were all that we wanted to do, the user tells you what you want to include on the pizza, and then you go do that associated work. So you could imagine thinking of this kind of like a builder. But for now, we're gonna say, what if there are multiple different styles to the pizza shop? We want to be able to make different pizza styles with the same instructions. So we'll get there in a second, but let's first add some functionality to our pizza shop. Right now we have a basic constructor and some methods that we can do to the finished pizza object, prepare it, bake it, cut it, and box it. So we want to allow our customers to order multiple kinds of pizza. We need to determine what they ordered. One way we could do this would be something that looks like this. So we're going to take a parameter into order pizza that is the type of pizza. And now the user can specify, I want a cheese pizza or a Greek pizza or a pepperoni pizza. And you'll have separate constructors now for what it's like to put together a cheese pizza, a Greek pizza, or a pepperoni pizza. And then regardless of the kind of pizza, there will be functionality in each of these concrete classes to prepare it, bake it, cut it, box it, and return it. We're already starting to see that if block created. We pass in a parameter, and now we need to figure out what type of pizza do they want. We need some kind of branch based on what type they want. So we're seeing this issue start to present itself already. Oh no, our competition has decided that they're going to make some new trendy pizza types. So in order to add these new trendy pizza types to our menu, we need to make the changes. So first of all, note, is our pizza open or closed for modification? Based on the code on the previous slide. Closed for modification? That's right, because we have to go edit our code. We can't just add a new class and call it good, because we need to actually go back to this if, and we're gonna now be accepting new different types in this parameter type at the top. Which means we need new blocks in the if statement. So now yeah, so this is not closed for modification because we need to make these associated changes. We expect that all pizzas get prepared, baked, cut, and boxed, but we also don't know what types of pizza we're gonna be adding, if we're gonna be changing certain types of pizza, if we're gonna be removing some because nobody ever ordered the Greek pizza, so we're just gonna remove it from our menu. How much work is it to remove it from what's possible? So we're gonna be modifying this block of code a lot. And now we want to add a clam pizza and a veggie pizza because the pizza shop across the street has done the same thing and they're taking all of our business because nobody wanted the Greek pizza, but now everybody wants the new clam and veggie pizzas.
But pizza sounds kind of gross though.
Obviously, we're not yet part of this fad. This fad has not happened yet.
I hope I never see Lego pizza.
It's the new pineapple.
Actual pineapple is better than pineapple, frankly.
I'm a huge pineapple fan. So ideally, we want to move the object creation from this method, order pizza, and create our own class or our own way to worry about this. The constructor should worry about which type of pizza we are making, not some arbitrary method. So we want to now encapsulate the object creation into its own class. Kind of like we did before with the builder, except this is going to be a different way to do it, and we will see that it works for a very different kind of construction, when there are different classes of construction. Because what we're gonna see is we want to make exactly the same type of pizza, a pepperoni pizza, into like a New York style or a Chicago style. And the instructions are going to vary based on which type of pizza, even though it's the same type of pizza, it's the different style of pizza that we're making. So that's where the factory really shines. If we have a certain set of instructions, those set of instructions remain the same, but they are slightly varied in the execution of those, and they kind of branch from there in how you do it.
Is it kind of like multiple builders then, or?
Kind of, except that we want to be able to specify that right away.
Wait.
So we would have to specify, the client would have to know which director to call. And we don't even want that.
Wait,
We want there to be different object
wait,
types.
what do you want the baking the pizza to be different from the cutting, boxing, yada, 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 yada?
Yes, that one's already taken care of for us for now. But we want to, instead of having this large if block, we want to take that out of this order pizza, and we're going to make what we're going to call a pizza factory object. A simple pizza factory object. All of this decision, that is which type of pizza is going to live in this pizza factory object. Then the order pizza method just has to call some aspect of this simple pizza factory class in order to get it to instantiate the appropriate kind of pizza that was passed in as the type in the order pizza method. So a factory is a constructor method that also has the benefits of a class. We saw this a little bit with the builder, and we see this a lot with the construction types of design patterns, the creational types. So the factory is going to handle all of the details of the object construction so that the user does not have to worry about it. So a simple pizza factory is going to have a create pizza method inside of its object. Now note that this is not yet a field. We make a pizza, we set it to null, and then we bring this block. If the type is cheese, pepperoni, clam, or veggie, we're going to make the associated different subclass of pizza based on this abstract type pizza before we eventually return the pizza if we make it. So the code is still exactly the same as it was in the method, except now it's in a single class.
And this is just, you can keep adding more else's as more types are added. You go on and on and on and on and on.
So what's the benefit of this? Have we saved anything? Are there any benefits over doing this over the other approach of just having this inside of the order pizza method?
You can add as many pizzas as you please, or remove. Just,
How much work is it to add a pizza?
it's just one out of statement later, done.
That's exactly right. There may be 50 places in your code where you want to create pizza. But now, all of them point to the same class, this simple pizza factory. So instead of duplicating this entire block over and over and over and over all over your code, you're duplicating, making a simple pizza factory object and referring to this code. So if you want to add a new pizza type, you make one modification inside of here, and that will propagate to all of the places that make simple pizza factories. So now, instead of worrying about an arbitrary number of places, we're worrying about one. It still has the same principle of we have to modify this, but at least now we only have to worry about modifying one place. So not perfect, but definitely better than it was. A simple change like this can make a huge difference in terms of how much work it is to modify your code, to make changes to your code. So the benefit is that we can call this code from anywhere. If we need modifications, then it's going to be seen by any code that calls this code. There's only one if block instead of an arbitrary number of if blocks. There's one other huge benefit. If you have multiple different factory types, you can make an inheritance hierarchy of factory types. So instead of having a simple pizza factory, you can make an interface for pizza factories and then make a bunch of different concrete pizza factories. So you could have a New York style pizza factory and a Chicago style pizza factory that all have the same methods, but then specify when you make a new pepperoni pizza, if you had a New York style pizza factory, it would make a New York style pepperoni pizza. And it would know what kind of pizza factory it was. So you can take the inheritance hierarchy of different pizzas, throw that inside of an inheritance hierarchy of different pizza factories, and then you can create different classes of objects.
But could you use pizza factory, like in the pizza factory, and it have like the subclasses that each access a sub pizza type. So New York cheese pizza, New York pepperoni pizza, Chicago pizza, cheese pizza. Kind of like a inheritance hierarchy type SP.
That's exactly what we're going for.
So in one base factory, they have bazillion variants.
Yep, you can make an arbitrary number of different kinds of pizza factories,
So I know, I think I get pizza tomorrow, actually.
right? This is starting to sound good. Everyone is wishing that they had had pizza. Oh, absolutely, for the price too. So now that we have this factory class, we need to be able to interface with this and communicate with it from outside. So we've made a simple pizza factory. We need to be able to make pizzas with our simple pizza factory. So we are going to have a pizza store driver class. Our pizza store driver class is going to be composed of a simple pizza factory. So remember that we prefer composition over inheritance. But if we have an inheritance hierarchy, we want to compose the objects that use it. So a pizza store is going to have, think of it like the kitchen in the back of the pizza store. We're going to identify, here is the factory, here's the process we're going to use to make pizzas at this pizza store. So the constructor for a pizza store is going to take a pizza factory. Think about that for a second, think about why that makes sense. We're going to set the field, so we need to have instantiated some kind of pizza factory, and then we're going to shallow copy associate it with this pizza store object. Does the kitchen have to be part of the pizza store? Could it be a kitchen that's out back? Could it be a kitchen that's across the street? It technically could be. There's a little bit of design issue with that because pizzas are actual objects, but think of them as digital objects. If this is just a pizza image, the pizza image could be generated by a computer all the way across the world and then sent to you. So the pizza factory is now decoupled from the object. It's not put together where a certain pizza store, it uses a factory, but that factory doesn't necessarily, it's a different object. Now when we want to order pizza, instead of having to query the user or deal with that logic itself, it offloads that to the pizza factory's method. So we call the factory's create pizza method passing along the type, and that returns to us the associated pizza. And now from the order pizza method, it doesn't even have to know what the type of the pizza is. It doesn't have to figure that out. It just plays the middleman of what kind of pizza do you want? And then it passes that information along. Note that the type here could be absolute gibberish and it would still pass it along to the create pizza method in the factory. The factory now decides, can I make this pizza or not the order pizza method. The order pizza has become a middleman. So there's no new operator inside of the order pizza method. The new happens in the pizza factory. Questions on this so far? All right, this is a simple factory. So far, not a design pattern, but it's still frequently used. A simple factory is just an object-oriented technique. We'll take a look at the UML for it here real quick, and we're basically out of time. But we have the pizza store, interacts with the pizza factory, that makes a pizza. And then from the pizza, we have an associated inheritance hierarchy. So the pizza store is composed of a pizza factory, is composed of a pizza, which is itself an inheritance hierarchy. This is just using composition so far. So again, not a design pattern, it's just composition. But we're going to talk about how do we take this idea and now turn this into an inheritance hierarchy with different styles of pizza. And we'll talk about that tomorrow. Start thinking about the UML for your project. I will go make that live so that you can refer to the document that we went over today and start thinking about that. Get your decorator in by Wednesday. I'll also be assigning the builder lab within the next day or two. So you can get started on that.
Is that gonna be due next week?
Probably,
Yeah.
I can't imagine that it's due the same week as the exam, on top of the exam, on top of something else that's due on Wednesday.
Do we know when we will get the results from the first lab, so we have like an idea?
Within the next day or two. I actually just had a meeting with the TA today about it, and she had questions for me, we talked about those, that she thought she'd get them done in the next day or two. I wanna make sure that you get that feedback before the exam on that topic. That would be ideal. But thanks for asking, that's a very good question.